More than 250 experts in the traffic signals industry joined together in person to hear a range of papers here in Nottingham. These recordings are brought to you by AGD Systems, Colas, SRL Traffic Systems, Smart Video and Sensing, Vivacity and Unex Traffic.
There we go. Thank you very much. I don't know what I've done this morning to upset JCT, but they've given me the red eye slot. So I must have upset John and his team here to come in on the second day of the actual symposium. Good morning, everybody. Thank you for coming this morning, and welcome to day 2 of the symposium itself. Well, today I'm going to present to you a project that we as Smart Video and Sensing have done with Portsmouth City Council and I was going to say Highways England, National Highways as they are today, on the M275 motorway in Hampshire, which is one of the major routes into the city of Portsmouth. It's a combination of our TRUGRD stream, as Paul said, the radar and CCTV combined unit, and our NOVUS data aggregator. Just seem to move forward. There we go. Just by way of some background, Smart Micro as a company, a German company, have been in business for a number of years, and any of you that drive a vehicle from the Volkswagen Audi group, or even today Renault, Citroën and several others, will probably have a Smart Micro radar in your vehicle for your lane guidance or another thing. They moved into the roadside radar business about 2017, and they've got over 100,000 units currently installed around the world. So just give you a bit of background into Smart Micro themselves. We first brought the radar to the UK in about 2018 to work with Highways England on their Midas systems. We're still trying to get there with them. It's been a difficult journey, shall we say, with a lack of priority, I think, from Highways England, that particular product. So I decided to make a strategic move, leaving Highways England to do their thing with our Midas radars, but then I moved on to to put our concentration into the urban traffic market, which was a great decision to make. As you're aware also that major road schemes demand an awful lot of modelling these days, and I know that Darren from the DFT talked about data collection the other day and how important it is, and we were very fortunate to secure some grant funding from Innovate UK last year to develop our NOVUS data aggregator, which we've designed to work with the Smart Micro radars to allow you to collect data at the roadside. And the NOVUS can be fitted to an existing Smart Micro radar installation to give you an upgrade to data collection at any junction, so without impairing or interfering with whatever you've put the radar up there in the first place for. So our thanks to, as I said, to Innovate UK. Okay. Let's take a look at what we've actually done on the M275 in Hampshire. It's great having 2 screens here, by the way. I feel like stereo. The challenge for us was quite significant. The client there was looking for data collection, queue detection on the M275, and for those of you who don't know, Portsmouth is the UK's only island city. It's built on Portsea Island. There are 3 main routes onto the island. The M275 motorway is one of those routes. It's quite interesting that the M275 is actually managed by Portsmouth City Council and not Highways England, although they do share some of the maintenance. So we included National Highways in the project and shared the data with them. It's an odd motorway. It's got a number of intersections on it which don't follow the regulated distance between intersections. So it does suffer from queuebacks onto the motorway from some of the roundabouts and off-ramps on the motorway. So it was important that the council got early knowledge of any queuing traffic. So that was one of the things that we really had to do. They also were interested in monitoring a bus lane, and they were interested in just general data, general traffic data from the actual motorway itself. Those are the two products concerned, and it was quite fortuitous for us that I've been told I've got to use the laser pointer on this side, that the Smart Micro company had just released the TRUGRD stream there at the same time that we were developing our NOVUS product. TRUGRD stream gave us a radar with a 2 megapixel camera built in. The radar, as it says there, covers up to 300 meters, or 984 feet for those of us still back in pounds, shillings and pence. It's fully programmable. NOVUS can collect speed gap, headway, runway vehicles, classification of vehicles, a number of other facilities, and you want to talk about it in more detail, please come and see us today. NOVUS takes the output from the radar and can either send it, store it on board on its onboard SSD. We can add up to a terabyte of storage on the unit itself, and we can push that information. Back to your back office if you so desire. It also classifies, as I said, you've got pedestrians, bicycles, motorcycles, passenger cars, transporters, short trucks, long trucks, quite a few classifications there, and as well as having the data on board, you can also, if you want to store your data longer term, you can also add an external hard drive to the unit as well. And one NOVUS product will work with up to 4 Smart Micro radars. Okay, again, just the location that we're talking about there. That's the section of the M275 that we're looking at. The gantry there shown is the one where we've installed the products. There is a bus lane, as you can see, in the top part of the slide there, which we're also monitoring. And as I said, the motorway is prone to quite a lot of congestion, especially you'll know this, especially if you drive in and out of Portsmouth on a fairly regular basis. And it gives you another view of it there. We tend to get a build-up of traffic at the Tipner Park and Ride roundabout, which is the second one down from the M27 there. That particular junction feeds a park and ride scheme, an industrial estate. The park and ride scheme currently has facilities for 625 cars. It's a very good park and ride scheme for Portsmouth, and there are plans to upgrade it to 2,650 vehicles with a multi-storey car park there and some other commercial enterprises. So it's, as you can see, it's a busy road. They've reduced the speed limit on that particular motorway down to 60 miles an hour as well, because of the regulations, I believe, the distance between the junctions. And at the bottom end, as it approaches the city centre and becomes the A3, there is a major route from the ferry terminal. The ferry terminal is a passenger and cargo ferry terminal to France at the southern end there, and comes directly onto the motorway. It's a quick view of the installation itself there. You can see the NOVUS unit in place with the modem at the bottom. Now currently we're using 3G, 4G comms from the gantry position. That's one of the installations. We're using 3G, 4G comms on that. The plan is to connect it to Portsmouth's Wi-Fi mesh system as soon as British Telecom gets some of the ADSL points in place. On the right-hand side there, is a view of the traffic management configuration tool, which we use to program the radars. And at the bottom there of that particular slide, you can see down here, you can see the data collection that's going into NOVUS, and in this case, the vehicle classifications, speed, and it's an overview of or summary of the complete data collection side. And in the top right-hand corner of the slide is the CCTV view that the radar itself has. And in the case of Portsmouth, what we've done there is we've given them access to the CCTV. NOVUS will actually send out an email and an SMS message to the operators at Portsmouth. That allows them to remote into the product to see what the actual congestion's like, as well as having had it reported to them. Fairly self-explanatory slide here. We set the triggers within the software for the radar itself. As I said, types of triggers, what we can put in there: presence, speed, classification, stop vehicle, etc., etc. And as I said, the NOVUS will send out alert messages as appropriate, as and when required by the client. Okay, this is a view of the unit looking, I think, towards the city, and I think I should get a bit of video on this. There we go. A bit of video on this afterwards. So the video we're capturing in 1 second slots, so hence the way the vehicles are moving. But you can see from the actual trace on the side there how we're actually seeing the vehicles move in the lane sections that we've actually set. There's a pedestrian and cycleway on the, if you look at the image there, if you look to the left of the image, there's a pedestrian cycleway there. We weren't asked to monitor that, but we noticed when we set the radar up that we were picking up pedestrians and we were picking up bicycles as well on that particular route. The colours that you see on the screen here in the software, basically the indications of the range factors within the product. So for instance, the green area there is where we guarantee to be able to pick up pedestrians, and that's at 125 metres for this particular product, or 410 feet for those of us still in pounds and pence. The cyan colour, the next stage is motorcycles, 180 metres. Red is for passenger cars, and the rest of it is for trucks. I'm not saying that we cannot pick up smaller vehicles in some of those other areas, but these are the areas that we actually recommend as the given areas for detection of those classified objects. Another view. That gives you another view of the road itself. We've taken away the Google map, which you can drop into the software to set it all up. Taken that view away, just leaving us with the lanes, and you can see at the bottom there the data collection within NOVUS itself. And in that case, this is per vehicle data that we're capturing, and we're also, as I said, monitoring the bus lane itself. I wish I hadn't made these pieces of paper so big because they're a bugger to play with. And anyway, for the data, for those of you who are into data, that's what comes out of the radar. It's hexadecimal data that comes out. That goes into NOVUS. NOVUS actually then takes the data into a more usable format, shall we say, formats the data, and then and you can see the software of the NOVUS product there on the right of the screen. Each radar is identified by its serial number, so you know within the software which radar you're looking at, which radar the data is coming from. And as I mentioned before, one NOVUS unit can handle the data from up to 4 radars. Okay, the data can then be pushed forward in a CSV format to Excel, and with the use of some clever pivot tables, you can turn it into a graphical format, as you can see there. that's quite usable. We've been looking recently at integrating the output from NOVUS, and we've been talking to Denique for the in-city system. We've been talking to Drakewell for some of their back office systems. It's quite a usable, user-friendly format. Just by way of another installation that we've done in Portsmouth, this was the first one that we did. This is where we actually did comparison between a fixed data site on the Eastern Road in Portsmouth with our radar, and we actually did a comparison of the data accuracy. And even though the radar wasn't in the ideal position, we had to take the position where the Portsmouth gave us. So it wasn't ideal. The radars are not in an ideal position on the gantry. They could do with moving more into the centre of the gantry, but those are the results we were getting there. And I think you agree with me that they're pretty impressive. And that was independent verification there as well. It wasn't us that did it and reporting good figures to you. So next steps, and Portsmouth's pretty pleased, so I guess we've got a win there with them. They're planning on more NOVUS and TRUGRD stream rollouts in the town. We have already put since I put these slides together, we've already put 3 or 4 more radars in place. We've put one at the entrance to the ferry terminal where we're watching queuing traffic. I've gone on to red, I didn't notice that, sorry. Where we've gone on to the ferry terminal, where we're watching queuing traffic coming out of the ferry terminal onto the A3, which is quite important. And finally, I guess we've also now gone into Blackpool. We've got a site on Blackpool Promenade. It's the Portsmouth ferry terminal one there. And since I'm overrunning, I thought I'd better bring this down to an end, and quite fortuitous. And Blackpool, we're also looking at potentially more radars, on the TRUGRD stream radar and a NOVUS up in that particular installation. So that basically gives you an overview. If you'd like to know more, please come and see us on the SVS stand. Thank you. Sorry about the overrun.
Okay. Thank you, Peter, and congratulations on successfully spelling queuing that nobody does, but you did on that presentation. So just if you can put your hand up if you want to ask a question, and a reminder if you can say who you are and where you're from, what company you're from, when you ask your question. While you're thinking about a question, I just want to say, it's interesting, you talked about the cycling and pedestrian part of it, which of course on the M275 hasn't been required. I take it, is that a key thing for the harbour and especially for Blackpool?
Well, yes it is, Paul, and as I said, it wasn't required, but on that we had a pedestrian walkway and cycling route alongside the M275, and lo and behold, we were picking them up, so Portsmouth thought, oh, yeah, that's great, I'm glad you can do that. We have got another version of our smart micro radar, the 132, which is particularly good at pedestrian and cyclists, and in fact, City of Plymouth are putting a number of those in on a major route within the next couple of months.
Because I guess that's lucky timing, really, because in the last 18 months, the whole focus of active travel, so being able to accurately monitor it and count it is really useful. So that's one of the good things, I guess, that has come out of the horrors of the last year and a bit.
Absolutely.
Anyone got any questions for Peter? It was a very yep, there's one up in the middle for whichever one of you wants to run up and take it. Very comprehensive presentation. So he answered most of the questions that I was thinking of before I got to ask them. So we'll just have one question, and then I think you're free to go, Peter. So.
Okay, Tom Siddle, Four-Way Consulting.
Hi, Tom.
Have you done any studies to compare the accuracy of the classification between forward-facing and rear-facing?
I believe Smart Micro have, yes. And the radar works with both, to be honest with you, Tom. It works on forward and traffic that's moving away, yeah.
I know where we've used the standard UMR, it certainly works that way, but the classification was just sometimes rear-facing seemed a little less reliable, but that might have been the mounting height we had it at.
Yeah, and again, tweaking the positioning of the radar and the software actually can overcome that problem quite. It's important when you to basically have a look at what you've installed and make sure that the data you're getting back from it is right and what you've programmed is correct as well. It's like with any software tool, really.
Thank you.
Thanks. And can I just say also, in case somebody asks me, and Mark Playdell's not here, yes, we are going through the Topaz approval process at the moment, because I thought Mark Playdell would be here today, and he would ask me that question. But,
we've had half the questions we normally get with the absence of Mark Playdell, actually. One more question just there, please.
Yeah, Rob Perry from Dorset. Just interested to hear your views on weather issues with the detector. Do you get any loss in accuracy with bad weather conditions?
Again, Smart Micro have trialled the radar all over the world. China, it's been trialled in some very cold countries, a lot of snow and stuff like that. And we've got some data which shows very little effect. I mean, if we're in monsoon type rain, then yeah, but the radar itself, it's and funny enough, I was asking Smart Micro this question the other day. It's actually it's so sophisticated. It's looking almost at the frequency of the rain and the object that it's looking at, and it almost takes the speed of the rain into consideration while it's looking at the. Come and talk to me on a day. I've got Smart Micro over there with me today. Isabel from Smart Micro is here, so she'll tell you all about it. But
wonderful way to get out of a question.
I know. Too difficult.
Let's rescue Peter now and thank him very much for a really interesting presentation. Peter Eccleson, everyone. Thank you.
Thank you very much.